first thing what we do, we execute a command, for example kubectl run nginx, and we give it a image which is also nginx. Okay, so this is a command that we're going to give. Now what happens is this command would be passed on to the Kube API server first. So what this Kube API server does is it takes this command and it does the API server side validation to ensure that all the criteria match. For example, if the particular syntax is correct, if the particular image is correct, everything, the validation would be done. And then it will also check if the particular user who is giving this command has enough permissions to create a pod in the cluster. It uses RBAC, role-based access control, and other mechanisms to understand if this user has the permission to create a pod or he has only permissions to view the pods. Based on that, it would accept or reject the request. So what it does, once it goes through all this mechanism, once Kube API server checks all these mechanisms, it would make a entry that a pod needs to be created on the etcd data store. Okay, and then it gives a response back to the user that a pod has been created, but the pod has not yet been created. It just gives an output to the command. For this command, an output would be received to the user that a pod is created. Now what happens? Now the controller component of the Kubernetes comes into action. Okay, so this watches for all the changes in the etcd data store, and it cannot watch directly again. It has to go through the Kube API server, reach the etcd, go back to API server and the controller manager components. So it sees if there is any new pod request given by any of the users, if there is a delete request, or if there is any kind of request in the cluster. And now it detects that a new pod needs to be created and takes action to ensure that the desired state matches with the actual state. Okay, so desired state is the command where we are desiring for an nginx pod to run, and the actual state, there is no pod running yet. A pod needs to be created. So the controller manager takes care of this process. So the next component which comes into play is the scheduler. So etcd data store, it is updated that one pod needs to be created, an image to be nginx, everything is updated in the etcd data store now. So this request also will have a default CPU constraint and default RAM constraint, everything. If we are not specifying it in this command, an automatic allocation that's defined for the particular namespace would be allocated. So scheduler will go through and check how much CPU, how much RAM is requested by this particular pod. And then now it goes through and scouts the cluster for all the available nodes. So it will check node 1, node 2, node 3 and node 4. And now the scheduler determines which of the nodes have enough space to accommodate this much amount of CPU and this much amount of RAM. And then the scheduler would again update the data that, for example, if node 1 has enough space to accommodate this particular container or the pod, it would be updated in the etcd data store. Okay, so again, now what will happen? The controller manager will make a note of it, and now the Kube API server will send a request to the kubelet of the node 1. Okay, this node 1 kubelet. So the request would be passed over to the kubelet of node 1. If scheduler has assigned node 1 as the priority where the container is going to be placed. Okay, so now the kubelet takes action and it pulls the images from the image repository, and then it starts creating the containers in the node, and finally a container would be placed in the node. So for a node to be placed, all these steps should go through. Only then a pod or container can be placed inside a node. And once everything is updated, kubelet will again connect with the Kube API server, telling that the pod has been created successfully, and the same information will be updated in the etcd data store, that the cluster creation or the container creation is successful. And you can validate the request by passing in the command kubectl get pod. You would be able to see that a nginx pod is running on this cluster. If you have any further questions or suggestions for future videos, please leave them in the comments below. We value your feedback and look forward to hearing from you.